Hiya. So this is episode 4 of Snake. So what we're going to do in this episode is start putting the apple into the game. I'll just quickly remind you where we got to. So in the last episode we could control the snake and it's moving on a grid. So let's start with the apple then. I'm going to be looking at my notes so that it matches the PDF that you can download to go with this project, and everything will match. So we're going to create an apple, and the apple is going to be a JavaScript object, so denoted by these curly braces, just like we did for the snake. And the apple's going to have its position stored in there. So let's make a function for this apple to move it about. So we're going to say const apple move. So this is a function and it's going to do a few things. So we need apple.x. So this is like we did with the snake.x, and it will be a property of this apple like we did here. It will just add them in as we need it. So the apple, and what we need to do is we need to make it a random number. So we can use the math.random to generate a random number, but the random number will be between 0 and 1. So we don't want that. Let me just get the console open. So if I do, let's just do, let's console log this, console.log, and then we'll do apple.x. So we're going to console log this, and to do that, I'm just going to do this. Obviously you don't need to add this to your code. I'm going to call apple move. I'm just going to call apple move inside the update loop, just so it will run this. This shouldn't be here, but I'm just going to put it in there for now. So you can see what it's doing is generating a number between 0 and 1. So we don't want that. We need a number between here and here. So we need it somewhere between 0 and 20 for the board size, or 0 and 19. So our range should be there. So what we need to do, we need to times this number by our board size, because if you change your board size, it'll be different. So now you can see we've got numbers that are ranging from 0 to 19, but we've got lots of decimal places, and obviously our grid doesn't have decimal places. So what we need to do is wrap all of this in a math.floor. And a math.floor, what that will do is it will remove the decimal component, and it will round the number down. So if it's 2.9, it will round down to 2. And if it's 2.1, it will round down to 2. Just be careful if you're doing that with negative numbers, because if you do it with 0.9, it won't round it down to 0. It'll round it down to -1. So just be careful with negative numbers and floor, but it's a very, very useful function. So now you can see we are getting the apple X in the right range of numbers. So we don't need the console.log, and we don't need the apple move. But what we do need to do is copy this and do this for the Y. So that's the same calculation, but the apple X and Y are separate. So let's just put this back. That's me. So whoops, I'm just losing me. So what we need to then do is to get the apple moving to generate a position. We don't want to do it every frame. We want to do it at the start of the game. So when we've got this onload function, we're going to do it just before we start drawing. So we'll call apple move. So when the game loads, it will go to apple move. It will come all the way down here. It will generate a position for the apple, and then it will go to the draw loop, and inside the draw loop we could draw the apple. So we could do that inside here, or we could make a function. I'll leave that up to you. I'm just going to put it in here. So let's draw the apple. Okay, so we need ctx.fill. Oh, I'm just going to copy this. It's probably quicker. ctx.fill style. We need a red, so RGB. So if we have an F00, that will be red. We don't want to fill the whole canvas though. What we want is apple.x. And we need to times it by the cell size as well. So if the apple is at 15, we need to do 15 times the cell size. And then apple.y times the cell size. And then we don't want it that big. We want it to be cell size and cell size. So there we've got a random apple. If I just refresh the page, you can see that the apple does appear in a separate place every time. Do we do anything else with it? Oh yeah, we're gonna collect the apple. Okay, so let's go and collect this apple. So to know if we've actually hit the apple, so if I was coming down here, at the moment there's no collision. We don't know if we've collected it. So if we've actually collected it, what will happen is that the snake, the head of the snake and the apple will be in the same cell. So what we need to do is check, after we've updated the snake, is it now in the same cell as the apple? So we could say if snake.x, so the snake x position, is equal, and that's a double equals because we're testing equality. One equals is where we're assigning a value. So if the snake x equals the apple x, then they must be on the same square. Well, they are on the x direction, but we need to check the y position as well. So we use and, double and the snake y is equal to the apple y. If those two things match up, the snake and the apple have the same x and they have the same y, then they must be on the same square. So in this case, what we can do is we can call apple move. So what that will then do is move the snake to move the apple to a new location, and it does seem to work. So we can now collect it. So when we collect it, you might want other things to happen. So in another episode, what we'll do is we'll make the snake grow longer. This is the place where you would also add a score and trigger anything else to happen. You know, if you wanted any particle effects or anything else to happen in the game, you could trigger that from this little bit of code here. So that concludes this episode, and I shall see you in the next episode.